So remember from yesterday, take out your notes from yesterday. Look at it to start today's little Padawan practice. Remember, you should start with finding what first? What did you find first yesterday? AOS. And then AOS will lead you to your vertex. And then build your table around the vertex. Go. All right, so start off by identifying A, B, and C. What's A up here? What does that negative mean? Negative 1, negative 1. And there is no X term. So B is going to be 0, like we said. And C is that constant of 5. Hey, what do we already know then? The y-intercepts, right? We know the y-intercept has to be the constant 5. 0, 5 is our y-intercepts. All right, so now let's use A and B in our symmetry equation, AOS. So we're going to find the symmetry, or AOS is x equal to negative b divided by 2 times a. Well, our b value is 0 on top, and the opposite of 0 is still 0. And 0 divided by, doesn't matter what's down here, but it would be negative 2, would be x equals what now? 0. So there's the starting middle of our parabola. Our symmetry is x equals 0, which is also what part of the vertex? It's the y. Is it the y? It's the x, right? Because it goes right through the x value of 0. So that's our x value of the vertex. We'll put this right here in the middle of our table. We'll put the vertex here in the middle. And now we have a strategy of choosing values around that 0. So numbers that are less than that, like negative 2, negative 1, consecutive values, or 1 and 2. All right, so now we need the y values. So how are we going to find all these y values? Plug it into the equation. Plug those x's in. Plug these x's into the equation, but make sure you use parentheses. So let's do a couple down here. Let's do 0. That's easy, huh? Plug in 0 for x squared. What happens? It goes away, right? And you're left with just 5. And that makes sense. That's why it's our y-intercept. So our vertex is also our y-intercept. Okay? All right, now let's see what 1 makes. So remember, use parentheses. Negative on the outside, x squared plus 5. The first thing I want to do is the x value of 1. That right there. Put it right there. What's 1 squared? 1. And what's negative? That makes it negative 1. So it's negative 1 plus 5. 4. So 1, 4 should be our first output there. 2. Again, you could use parentheses, build a table on your calculator. Plugging in 2 would give you positive 4, but that's a negative 4 now because of the outside negative. And negative 4 plus 5 is 1. So there is the outputs for 1 and 2. Let's go ahead and plot these. 0, 5, 1, 2, 3, 4, 5. There's the middle of our parabola, our vertex. All right, there's our vertex, 0, 5. And now let's plot the other points that we just came up with in our table. 1, 4. And then the other one is 2, 1. 2, 1. Now, we could also finish a graph or the table using symmetry. Let's put in our symmetry line. So right through the, what axis is this right here? That's the y-axis, that's right. Let me get a different line here. So there is our symmetry line. If you can't see it, there we go, make it a little bit bigger. Okay, so it reflects. So this point right here, how far is it from the symmetry line? It's 1 away. So we should have another point reflecting 1 away in the other direction. Same thing over here. This is 2 away, so we should have another one right there. And we can see that symmetry in our table as well. these two values are symmetrical. They are matching y values. Okay, and then these are also matching. I mean, you see that either in the table or on the graph. Now, the hardest part for me is drawing the parabolic curve. So don't judge me, please. I gotta redo that one. There you go, that's not bad. Okay. Did anybody use the step pattern? Did anybody use the step pattern? Yes? Very good. Now, it's a little bit different because the step pattern that we usually use is what? 1, 3, 5. 1, 3, 5. Okay? But when A is not 1, like it is here, -1, we're going to multiply all of those by -1. And so that's what makes that new step pattern of down 1, down 3, and then I can't fit it, down 5. And always over 1. Let's see. At the vertex, I can go down 1 and over 1. That's -1. Let's draw that. Down 1 over 1. That's -1. What's the next step? -3. Down 1, 2, 3 over 1. Down 3 over 1. Down 5. Let's see how accurate my parabola is. 1, 2, 3, 4, 5 over 1. So I should have made it a little bit wider. That's that down 5 part. Okay? You can use that to help you build these graphs as well. Symmetry in the table, symmetry in the graph, okay, and also the step pattern. How is this one different? It's not in what form? It's not in standard form. Can we identify A, B, and C here? No. We have to convert to standard form. How could we do that? How do we get this into standard form? Unfactoring it, right? Don't distribute the power. Multiply x plus 3 times x plus 3. And then times it by 2. And then don't forget, minus 5. So go ahead and now convert this right now, everybody, to standard form. Do those steps. All right, so remember, do not distribute that power ever over a plus or a minus. You have to write 2 copies and multiply. You can multiply any order you want. I'm going to do this first because these square binomials make perfect square trinomials. So the 2 will stay, and then x plus 3 squared would be x squared plus 6x plus 9. Then I'm going to distribute my 2 inside to that trinomial. 2x squared plus 12x plus 18, and don't forget the minus 5 over there. That's right, 2x squared plus 12x simplifies down to now plus 13. And now we have standard form. Now we have standard form. But before we start finding everything else, you guys are so excited to find all those key features. Do you remember from last week what this key feature up here was? I'm not key feature, I'm sorry, form. Nope, not factored form. What form was that in your notes from last week? Vertex form, very good, vertex form. Vertex form. Take a wild guess what that form actually shows you. It does. It does. So let's remember to come back and look at this equation after we graph and fill the table out. Okay? All right, so now we have standard form. We can identify A, B, and C. So A is 2, B is 12, and C is 13. Okay? That's important because now we're going to find the AOS, our axis of symmetry. So AOS, x equals negative B over 2 times A. What's my B value? 12. And what's the A value? 2. So negative 12 over 2 times 2. What does that x simplify to be? Very good. Say it again. Negative 3. Negative 3. Negative 3. That x value is also the x value of what? The vertex. So let's go ahead and put that x right there. Make some more room. This is our vertex, and that negative 3 is our x value. All right, now that we have the vertex, we have our starting middle point of the parabola. Let's try to use our step pattern to build the parabola. So remember, what value determines the step? A, B, or C? A. A is the step pattern. So A, remember A, the number that A is will always determine the shape of your parabola. So if A is 2, we're going to take our normal basic 1, 3, 5, and we're going to multiply it by that 2. So 2 times 1, 2 times 3, 2 times 5. And so our new steps are going to be what? 2, 6, 10. Multiply 1, 3, 5 by 2. You end up with 2, 6, 10. All right, let's build it. So let's go to our vertex, negative 3, negative 5. I think that's negative 5. 1, 2, 3. No, it's not. So there's our vertex. It's a positive 2. So what does that positive 2 tell us to do? Up 2. Up 2. So I go up 2 and right 1. I went up 2 from the vertex, right 1. Can I reflect that over? Yeah, right? I can go up 2, I can go left 1. And you're always going over 1 either direction. All right, now we're at this point. Our next movement would be up 6. Up 1, 2, 3, 4, 5, and 6, and over 1. Sometimes your eyes can fool you. So let's put the symmetry line in there just so we don't make a mistake. That way we have something to refer to in our reflection. So there's our symmetry, our AOS of x equals negative 3. We definitely can see that reflection now on those 2 points. This is 2 away, so go 2 away this direction and put a dot right there. All right, now let's draw the parabola. Don't judge. That one's a little bit skinnier than the last ones because A is a bigger number. When A gets big, the parabola becomes skinnier. Okay, the y values stretch. All right, now could we fill out the table from the graph? Yeah, usually we do the table and then the graph, huh? It's kind of weird. We're doing backwards here. We could use these properties of parabolas to help us fill out the table now. Okay, there's reflection. So what's this coordinate we're going to put in right after to the right of the vertex? What's that coordinate right there? Negative 2, negative 3. So negative 2, negative 3 was that coordinate there. The next coordinate would be what? What's that one? Negative 1, positive 3. And then the other side of this would be negative 4, negative 3. Negative 4, negative 3. And there's that reflection again. And then consecutive value would be negative 5. Reflection would be positive 3. Positive 3. I know, it's crazy threes. Now look at this. Even in the table will show you this step pattern. How do you get from negative 5 to negative 3? You add 2. You add 2. And how do you get from negative 3 to positive 3? You add 6. Up 2, up 6. Next will be 10. So you can see this in the table and on the graph for your step pattern. Let's talk about this problem, okay? What can we know right now for A, B, or C? What can we see? That's right, we can see the y-intercepts. It's going to be 10. So we know our equation will be something with plus 10. Okay. Now, what we don't know is A or B. We don't know B. Can we see A on the graph? Yes. Remember, A is the step from the vertex. So going down to our vertex here, and I made a mistake one class. I went up 2, but is that really up 2 to the next point? It's up 3, because remember, it's the next x value. So sometimes it might be better to look down here and then go up. So it's going to be up 1, 2, 3 over 1. So that's 1, 2, 3 over 1. So my A is 3. My C we saw was 10. So now we know it's going to be 3x squared, if I could draw x squared there, and then something for B times x. So we have y equals that. So what we're missing is our B value. So some students were using the outputs, this -2, put in -2, and they were trying to get -2 as the outputs. And they were playing with numbers, guessing with numbers on B. So eventually a few people got to this number and got 12 was the right number. Okay, that would take forever if you didn't figure it out quickly. Okay, so instead of guess and check, there's a more efficient way. One way that I used to do it was I would replace x and y with a given coordinate and solve for what's left, the B value. But that's too hard, I saw, because we could also use a thing called the symmetry equation. Because the symmetry equation is simply x equals -b over 2a. And we have values for the a, which is what? 3. And how could we see the x? Remember, this is the x value of the vertex. The x value of the vertex. So what is our x value of the vertex? -2. So we could set up a simple equation and solve for B here. -2 is the x value of the vertex equals -b, which we don't know what B is, all over 2 times A. A was 3 from the graph. So what's 2 times 3? 6. So -2 equals -b over 6. How do I undo that?
Oh, wow.
How do I undo that? Multiply by 6 on both sides. Okay, that's going to give me, put it over here. That's going to give me -12 equals -b. And then what? Divide by -1 and you'll get B is 12. And now you can write the equation. Let me zoom out a little bit. A lot faster than trying to guess and check. Okay, a lot faster than solving all of these. Okay, it's a lot easier. So let's write the equation. Our answer will be y equals what? Tell me.
3x squared plus 12x.
Plus 10, that's right. There's our A, our B that we solved for, and the C we got off the graph. May the math be with you.